Okay, here we are again for another video. This time it's for lab number 3. So we are in week 9 through 11, and we are talking about chapters 9 through 11. And we're going to go under content on our course Blackboard, and we're going to go to that folder, and we're going to click on that, and it's going to take us in, and we're going to go down to the very bottom to the lab assignment 3 folder. We're going to click on that. And that is going to show us where our instructions are, our PSPP guide, and all of our data files are in there, right? So you can see my Blackboard's a little bit slow right now. That's not uncommon. So as soon as that opens up, you'll see the different files, right? So here are the actual instructions for the lab assignment 3. Here is the PSPP guide. So this tells you what you need to submit, what questions you need to do for the book problems, what data set to use for the PSPP part. But this is the one that actually tells you what to click on and gives you an actual example to follow for the PSPP part of the assignment. Here are the data files. We need to have PSPP to open those. And if you want to submit your PSPP output as a PDF, you can upload it here. And instead of printing it out and turning in with the rest of your work, it's up to you. So when you have the lab assignment 3 document open, you'll see, right, this is for all of our t-tests. So it tells you right at the top here, right, bookwork, PSPP output, and lab questions are the 3 parts that need to be included for lab assignment 3. Now remember, this is worth 50 points, so it's a big chunk of points. You want to make sure you have all of those things and that you get this in on time, because remember, 10% off is deducted for every class meeting late. 10% of 50 would be 5 points per class meeting late. You want to make sure you get this in on time, get all those points you can possibly get. Okay, so here we go. Bookwork is the first part. You can see here, chapter 9, 10, 11, right? I specify exactly which numbers of the problems I want you to do. They're all odd. The solutions are in the back of the book, not for you to copy the answers, but for you to use to check your own work. I'll be looking that you are actually doing the work, so please show all your work for the book part of the assignment. Now, what this video is really focusing on is the PSPP part of the assignment. And this is worth 20 points this time, so it's a big chunk of that points. So it's really important that you understand the PSPP part. So for your assignment, you're going to use the college data set, and you're going to answer, guess what, 3 different questions. You have part A, part B, and we're going to scroll down and you'll see there's a part C. And guess what we also have 3 of? 3 different types of t-tests. It's amazing. Yes, you will be doing 1 of each type of t-test for this lab assignment using PSPP. So the idea is that you calculate each t-test by hand by doing the book problems, and then you get to see how easy it is using the software when you do the PSPP part of your assignment. So you will submit your bookwork, your PSPP outputs for each kind of t-test, and then you will answer the 2 to 3 questions per t-test as listed here. So we'll come back to this assignment instructions. Let's go to our PSPP how-to guide lab for lab 3, right? So now we're starting with the employee data set. So what I did was I actually put the employee data set, I saved the file to my desktop, and then I double clicked on it and it opened up here. But I could have gone to File and then Open, and then I could have found, hey, look, on the desktop, there's my employee data, but I already have it open, right? So I like to have both the instructions and the data file open at the same time so I can see both, but you can do whatever works best for you. So here I have some little review at the top. So I'm reminding you that the APA format for reporting a t-test is T, parentheses, degrees of freedom, the actual t statistics, or the value we calculate for our sample t, and then the p-value, right? So the p-value, the difference here is PSPP is going to give us our exact p-value, whereas in class when we calculate by hand, we can only estimate the p-value or the probability value for our sample, right? Because that's essentially our chance of being wrong. So we need to remember that anything less than 0.05, because that's just our default alpha level, we're using 0.05 for all of our lab assignments. Anything less than 0.05 is going to be significant. So we're going to conclude significant difference in between our sample and whatever else we're testing, depending on what kind of test it is, okay? So that's our review, APA style, and we're looking for less than 0.05. So let's get started with our t-test problems, okay? So part A, one sample t-test. Here we have a situation, we have a research question, and guess what kind of t-test we're going to use? Just, right, spoiler alert, one sample t-test. So we say we're using the employee data set as our data, and the research question is, the owner of a company claims that the company's employees have on average 110 months of previous work experience. A sample of company employees is obtained and their mean amount of previous work experience is 95.86. Does this amount differ significantly from the owner's claim? So essentially we want to know, is this owner lying? If he's telling people that all his employees have on average 110 months, but the actual average for the sample employees that we collect is 95.86. We want to know, is this different enough from the 110 month claim that we should tell him, hey, you're lying. It's different, right? So we need to know because they're very similar. So what are we going to do? We are going to conduct a one sample t-test. Now the variable we are interested in is previous experience. So we're going to go into our PSPP data file. Remember, we always use the menu called Analyze when we're trying to analyze our data. And all of our t-tests are going to be under compare means, because no matter what kind of t-test we're using, whether it's one sample, independent measures, within subjects, whatever, they're all going to be here underneath Analyze and Compare means. Okay, right here, second one down, one sample t-test. So I'm just going to go ahead and click on that. Now, I'm interested in previous work experience, so I'm going to find previous experience in months, okay? And I'm going to click on the little triangle and move it over to my test variable box, okay? So here, this is my variable that I'm testing, so I want to test the mean for everybody for this variable, and I want to test it against the claim of 110 months. So I'm going to put in under test value, I'm going to type in 110. And again, that 110, this is my meaningful value. This is my null hypothesis. This is what we're testing to see if our sample is different from. Because remember, in our one sample t-test, we don't have population information. We're always testing a sample mean versus some sort of population meaningful value. And guess what? This is all we need to do. So we go ahead and we click OK. And you have to find, remember, PSPP doesn't automatically open up the output window. You have to go find it. So here, I went and found my output window, and I'll make this a little bit bigger so you can see it. It's pretty much the same thing that's on your guide, but we'll make sure we can see it. Okay, so let's talk about this. So here, right, we get our actual descriptives, our stats for our variable. So previous experience in months was our variable. We had our sample size, 474 people are in our survey sample from this employer, and their average amount of previous work experience was 95.86. So we knew that was in our question. But look at the standard deviation. The standard deviation is 104 months, so that's a lot of months of standard deviation. So we want to know, is there going to be a significant difference between this 95.86 months and the 110 months the owner is claiming? So we do a t-test, and look, we don't even have to calculate it. PSPP does it for us. So here's our t-value. Degrees of freedom is always n minus 1, right? And here's our significance value, so it's 0.00. Now I will say PSPP is limited to 2 values, so this means actually that our significance level, our p-value, is less than 0.001. It's so small that it doesn't even show up here. So it may be 0, it may not be 0. It's one of those hard things with probabilities. It's really that PSPP is so limited. But we definitely know that 0.00 is less than 0.05, so we say, woohoo! There are significant differences. So our conclusion in words is going to be there is a significant difference between the average workers, the actual average workers' amount of previous experience in months. So 95.86 is significantly different than the 110. And we see that the t-value is negative, so we know that the actual previous experience in months mean is less than what the owner claims. So let's look at this. Let's see what the conclusion will look like, because guess what? Your assignment is going to be to actually write up your own conclusion. So I want you to copy this part right here. And I highlighted it. It's kind of hard to read, but I'm going to read it to you. So our conclusion in words, we're going to use APA style as well, is that the employee's average previous work experience, we list the mean so people know what we're comparing. 95.86 was significantly lower than the 110 months claimed by the company's owner. Then we say comma, and this is where our little APA style comes in to save the day every time. T, degrees of freedom 473 equals negative 2.94, comma, P less than 0.001. So you can see this information for my APA style comes directly from my t-test. It's my t-value, my degrees of freedom, and this is my p-value right here. So this is very exciting. We have everything that we need for our one sample t-test right here. Okay, ready for your next one? Here we go. Let's move on. Moving on to our second type of t-test. Now remember, the one sample t-test was when we have one sample. So we have one sample mean representing our one sample that we're comparing to some sort of population meaningful value. Now that's not normally as frequently used in research as, having two different samples that we're comparing. So now, same data set, employee data set, we have a sample of employees here, but we want to compare two different groups within that data set. So now our new research question is there a gender difference in the average amount of previous work experience? Now, anytime you see a question asking about a gender difference or difference between groups, and the groups are groups that you can't be in both, right? So you're going to either identify as male, female, or maybe other, right? But you're not going to have multiple categories. So if we were talking about biological gender, you're going to have to choose one or the other. So that gives us a hint that we're going to use the independent samples t-test. So we're going to go again to our PSPP data set. We're going to go under Analyze, Compare Means, and we call it, I think our book calls it independent measures, right? You can call it between subjects. That's what I usually call it, is between subjects t-test. But again, these t-tests have several names, but they're the same thing. And PSPP calls it independent samples t-test because we're conducting a comparison, comparing the means between two independent samples, men or women, not in both, okay? So I click on independent samples and my dialog box opens up, and again I can kind of expand this. Now what am I interested in? I want to know, is there a gender difference in the average amount of previous work experience, okay? So what I'm testing, or what I'm measuring the difference in, it's my dependent variable, is previous experience in months. So I'm going to click on the arrow, bring previous experience over into the test variables box. But I need my independent variable, my grouping variable. So what am I comparing for a difference in? I'm comparing gender. Is there a gender difference in that? Okay, so I'm going to find gender, and actually I'm going to use sex of the subject, because what I'm going to do is I'm going to look at my actual data, my data here, and I'm going to say, okay, gender is MF, right? So this is called a string variable. It's not numerical, but sex of the subject is numerical, 0, 1, right? So we can see that female is 0, male is 1, and that's very commonly coded. So we want to use the numerical value. We want to have our grouping variable be a numerical value, so I click on the sex of the subject, click the little arrow next to grouping variable, and you'll notice that this box, define groups, it actually got highlighted as soon as we moved a variable over here. So we're going to click on this, and we have to tell them what groups to use. So we only have two groups, so I'm going to say 0 and 1. So this would be our females, and this would be our males, right? Now, the reason why you have to define 0, 1 is, let's say we were doing a comparison by, let's say, job category. And imagine that job category, there were like 4 or 5 job category types. Now, if we're doing an independent samples t-test, we can only compare 2 groups. That's it. One group versus another group, 2 groups is it. Now, if we had 4 possible groups, we could compare group 1, group 2, group 2, group 3, group 3, group 4, any possible comparison we wanted, but you can only compare 2 groups at a time. So you have to tell PSPP, remember, it's a computer program, which comparison you want to make. It doesn't know there's only 2, so we have to tell it. So here, we've told it 0 and 1, and it exactly matches up with how our variable is coded. And then we click continue. And guess what? Woohoo! We're done. Click OK. Don't you wish it was this easy to calculate by hand? Not that it's hard to calculate by hand, but yeah, that was fun. That was easy. And now we have a new t-test added to our output window that we had to go find and open up again. So now we want to say, okay, is there going to be a difference in previous experience? Now remember, previous experience is measured in months. So we have our sample of only female employees, and we have 216 female employees, and their average previous experience is 77.04 months. But they have a standard deviation of 95 months. That's a lot of months, right? And then you have your group of male employees, and you have 258 male employees. And look at that. So you have more male employees than you do female employees. And of those male employees, they have more previous months experience. They have 111.62 months, right? So again, it's a lot of months. But their standard deviation is 109.69 months. So this is a lot of months right here in the standard deviation. So we really want to know. We think, right, it looks like there's going to be a difference. But with such high standard deviations, you really need your t-test. You need to do your hypothesis testing and go through the full steps of, right, rejecting the null hypothesis and so forth. We can't just say, oh, yeah, it's going to be different. We don't actually know until we test it, because that standard deviation can throw us so far off. Okay, so this is my independent samples t-test. We call it independent measures in the chapter. You can call it between subjects. Between subjects is what I normally call it. It just is a preference, right? Just like our notation. So now here we want to test, we're either going to use the t-value for equal variance is assumed or equal variance is not assumed. Now this is what I was talking about in class, where we had the homogeneity of the variance assumption, and I said we could test this. So PSPP is actually going to test this for us, and it's this test here, and it's the Levine test of equality of the variances. So if they were significantly different here, if this was less than 0.05, we would say, oh no, there is a difference, and we would use this bottom test that would be more conservative and say equal variance is not assumed. But really, we shouldn't even do the test if we didn't have equal variances. But you can see this is above 0.05, so we can use the top line, equal variance is assumed, and we go straight over here. This is the t column, so this is the important stuff. So we want to start looking here. So this is our t statistic, negative 3.63, right? These are our degrees of freedom. Now remember, our degrees of freedom, we're losing 2 degrees of freedom, one for the female group, one for the male group. And here we have our p-value, our significance level. So again, you guys, we have 0.00. So that means there is indeed a very significant difference between our female groups who have an average of 77 months of previous work experience and our males, right, who have that previous work experience, and it's negative, so this is significantly lower, right? So let's look again at our guide. You'll see that it's exactly the same. Woohoo! And we have to write out our conclusion, because the conclusion is the important part. So we would say, okay, significance is 0.0, and so we would say 0.00 is less than 0.05, so we reject the null hypothesis. There are significant differences, so our conclusion in words is going to be, right, male employees of this company, and we give them mean, have 111.62 previous months of experience, right, that's what that is, have significantly more previous experience than female employees, and we give their mean then, 77 months, comma, this is where our APA style comes into play, t, degrees of freedom, 472, equal negative 3.63, comma, p less than 0.001. Now we're saying less than 0.001 because PSPP again is limited that it only does 2 digits here. So we don't know if this is 0.001, 0.000, and it's really 0. So of course we're researchers, we're more conservative, so we say that it's less than 0.001. But it's very small, tiny chance that we're wrong. So it does indeed look like there is a significant difference. We would reject our null hypothesis. All right, home stretch here. We're talking about our last type of t-test. Now, in class, we called this the repeated measures t-test. We could also call it within subjects t-test. I like to call it within subjects t-test. But PSPP, again, computer program that we did not get to pick the name of, calls it paired samples t-test. So paired samples t-test is what we call a repeated measures or a within subjects t-test. Now remember, this is the t-test where we're measuring each individual multiple times. So we're comparing each person to themselves, repeated measures. So we measure them at time 1, we measure them at time 2, we find the difference between those scores, and we find the average of the different scores, and we're testing to see if there's a significant difference, if there was a change, maybe over time or between measurements, right, within each measurement for each person, comparing each person to themselves. So here, same data set, employee data, we have a research question that says, is there a difference in the beginning and current salaries of employees? So we are going to compare the starting or beginning salaries of these employees in this data set, and we are going to compare it to their current salaries, so what they're currently making. So again, we're going to go under Analyze, we're going to go to Compare Means, and look right here, Paired Samples T-Test. Click on that one, and our dialog box opens up. So we're saying, okay, we're ready. What we're interested in measuring, again, is our beginning salary and our current salary. So I'll tell you a secret trick. If you click on both of these and then hit the arrow, it brings them both over and it puts them in the right place, right? Because remember, the order here matters. If you move them over separately, the order doesn't matter. It'll just affect if it's negative or positive. Not a big deal, but I would highlight both of them, and then you can hit Control and drag it over. You can highlight both at the same time, hit the arrow, it's up to you. And then all you have to do is click OK, and we find our output window. We scroll to the bottom, and looky here, we have a paired samples t-test. Yay! So we are excited. We are looking at our paired samples t-test, and we are saying, okay, so here's the current salary average is $34,419.57. Beginning salary average is only $17,000, or yeah, $17,016.09. And remember, again, we're doing paired samples, so we're going to know as a result of this test if there's a difference for each person, right? We're comparing each person's starting salary to their current salary. So we're not looking at anything but the within group comparison, within subjects comparison, okay? So we have at the end here, the important part, the second part down here is the t-test. And we say, okay, this was the pairing between the current salary and beginning salary. So our t-value is 35. Ooh, that's a pretty high. Think about our little distribution. So yeah, this is going to be different. That's way out there in the tail end distribution, super high. Degrees of freedom, right? We lost 1 degree of freedom because we only have one sample, but we're measuring that sample twice. And then we have our significance, our p-value. So our p-value is less than 0.00, right? So this is less than 0.05. So we say, yes, reject that null hypothesis. There is a significant difference between people's beginning salary and their current salary, right? So their current salary would be higher because this is a positive number, right? So we would say, yes, there is a significant difference, reject that null hypothesis. So we go back to our guide and look at that. Our conclusion is employees have a higher current salary. We state the mean. Relative to their beginning salary, we state the mean for the beginning salary, comma, here's that APA style we know and we love. T degrees of freedom equals 35.04, comma, P less than 0.001. And again, because PSPP only has 2 digits, we just know that it is less than 0.001, right? So we are estimating. So if we are, for your homework, if PSPP gives you an actual p-value that's not just 0, you will want to say P equals and write in the actual value there. Okay. We're almost done, right? We've done all of our t-tests. So now we say, okay, I want to turn in my PSPP output. So I'm going to go to File, Export, and here I have to write a name. So I'm going to give it a name, Lab 3, and I'm going to say save it to my desktop. And I'm going to click down here, right? So you saw how I typed in the name here, clicked on the desktop here, and I'm going to click from this menu, and I'm going to say PDF. And then I'm going to click Save. And when I minimize this, because I don't want to close it yet, look at that. My Lab 3 file is saved as a PDF, which is taking a while to open. Come on, open. Oh, it's opening another PDF. There it is. Okay, so you can see that I have all my tables there. And then I would want to, I'd say, okay, now I know what I'm doing. I know how to save it. I know everything. So I'm going to go back to my Lab 3 assignment file, right? And I'm going to go through and do this all over again, but I'm going to use the college data set. So here we have our scenario for our one sample t-test is part A, our independent measures, independent samples t-test for part B, and our repeated measures or within subjects, we call it now paired samples in PSVP here. So you're going to follow the instructions for the guide. You're going to answer these questions, right? So each one is the same kind of setup where you have a scenario and then you have 2 questions to answer. And what you'll submit is the actual answers to those questions and the output for that, right? Again, here you have 3 questions to answer, so you're submitting the answers to those 3 questions and the output. And here you have 2 questions to answer, so you're submitting the answers for those and the output, right? So your total assignment is worth 50 points. You're going to submit your bookwork for chapters 9, 10, and 11. You're going to have your PSVP output parts A, B, and C. So it's one sample, independent measures, paired samples, right? And then the answers to the questions for each. There's 2 to 3 small questions for each, okay? So you are officially ready to go off and get started on lab number 3. I hope this video was helpful.